those capabilities mean that if you have a US satellite that is relaying communications back and forth to Taiwan at a critical moment, and somebody's threatening to disable that, that has a huge impact on the safety and well-being of people here on Earth. And that's something that our technology can help and support.
Welcome to the Mission Matters podcast, a podcast from Shield Capital where we explore the technical opportunities and challenges of developing and deploying commercial technology to national security customers. I'm Maggie Gray.
And I'm David Rothside.
And we are your hosts from the investment team at Shield Capital. All views expressed by the hosts and guests on this podcast are solely their own and do not reflect the opinions of their employers or investment advice. References to any securities are for informational purposes only and do not constitute an investment recommendation or offer to provide investment advisory services. In this episode of the Mission Matters podcast, we sit down with Austin Link, the CEO and co-founder of Starfish Space. Starfish is building the future of rendezvous proximity operations, or RPO for short, for satellite servicing, beginning with space tugs for satellite life extension missions. Essentially, Starfish's satellites are able to attach to other satellites and pull them into a higher orbit in order to extend their lifetime in space. RPO are the maneuvers and technologies that enable one spacecraft to safely approach, navigate around, inspect, dock with, or service another object in space while maintaining precise control and collision avoidance. I know Austin often describes this as two bullets coming together to very lightly kiss without actually touching each other. The same technology for life extension can also be used to clean up orbital debris, otherwise known as space junk, to ensure crowded orbits can be free of clutter from other satellite operators, as well as a whole host of maintenance and U.S. government mission sets.
Historically, RPO missions, like life extension missions, have been prohibitively expensive for most use cases, of course, before Starfish. The RPO missions would require large, expensive spacecraft outfitted with several complex sensors to conduct the operations. With Starfish, they're revolutionizing the industry with their software-defined platform, which can conduct RPO missions with just one or two sensors and cameras at a tenth or even 100th the price of your traditional RPO satellites.
Since they were founded in 2019, Starfish has launched two technology demonstrator satellites, the OtterPup-1 and OtterPup-2, successfully deployed their software on an Impulse space satellite, raised more than $50 million, and closed contracts with government organizations like NASA and Space Force, as well as with commercial companies including SES. The founders, Austin Link and Trevor Bennett, are both aerospace engineers who met while working together at Blue Origin.
In this conversation with Austin, we'll cover everything from the role of RPO plays in the U.S. military operations, the current state of our adversaries' orbital warfare capabilities, and of course, how to navigate the United States government contracting process as a space hardware startup. Okay, Austin, it's great to have you with us. Thanks so much for joining us on the Mission Matters podcast.
Good to be here. Thank you guys for bringing me on.
Yeah, I'm sure you're a first time, long time with this podcast medium, but Maggie and I are just super excited to have you here. So we want to jump into it. In December, as a little pre-Christmas gift, I don't know, maybe to your investors, maybe to the space economy, you and Impulse came out with a pretty large announcement about your mission, Remora. Can you tell us a little bit about it? I mean, how did it come together? The partnership with Impulse Space, it's really cool. And then what are the implications for Starfish as a company? And then, I don't know, maybe wax poetically about the broader space economy.
Yeah, so we announced in December our Remora mission. And on our Remora mission, as Starfish, we put a camera and some software on an Impulse Space satellite. And they allowed us to take control of their satellite and fly it towards another Impulse satellite. And we're not just flying it from the ground. We flew it autonomously on board and used our cameras to take pictures of the other satellite. And we got 1,250 meters away, which is close proximity operations when you're in space. We got some awesome pictures of them, and we got a chance to validate a bunch of our technology and gather a bunch of data to anchor it and anchor our simulations going forward. And this was a big mission for us for a few reasons. Number one, this mission touches on the kind of core thesis of our company, which is we can use software to make it easier to do rendezvous and proximity operations among satellites. And making it easier to do rendezvous and proximity operations is what ultimately allows us to build our Otter satellite that does the life extension and satellite disposal at a price point that commercially works. And it's what allows us to show up to Impulse Space less than a year before we're going to launch and drop some software on them and drop a little bit of hardware from TRL-11 on them and get to space and have it work and do a proximity operations mission. And so it's just awesome to announce doing anything in space. That's always super fun. B, it really validated a couple of our core theses on, hey, look, we can do proximity operations with easier than it's ever been done in the past. And then the last thing I would say, it was an awesome chance for our team to showcase their capabilities and for the Impulse team to showcase their capabilities. They were really a pleasure to work with, and they're a super impressive team.
Yeah, so it sounds like with this mission, you guys have really demonstrated that you actually can, get two satellites relatively close to each other and take a look at each other, maybe do some servicing. I want to turn to what this demonstrated technology can actually be used for. And maybe the first topic on that is the US government use case. I think previously it was relatively taboo for the US government to talk much about their space operations. However, I know that's changed in the past 2 years where concepts like orbital warfare, Golden Dome, space control are now actually being discussed publicly by top military leadership. So how does a capability like what you demonstrated with this most recent mission relate to some of these military mission sets?
Yeah, sometimes in trying to describe our company, I say we build satellites that grab and move other satellites. And that always raises the question, who the heck wants that? What's that useful for? Sure, it's cool, but how as a business do you provide value and through that get money so that you can continue to exist as a business? And for us, with our Otter, there's really two core commercial missions that we focus on. One of those is the life extension of geostationary satellites. You run out of propellant, we can grab on, hold the satellite in that slot still. And the other one is satellite disposal and constellation. So this satellite has died, it's occupying a slot, it's threatening other assets. Just get it out of there so that a replacement can be put in. You can continue to operate your critical space infrastructure. Both of those apply to the government the same way that they apply to commercial satellite operators. That there are many organizations inside the U.S. and allied governments that operate satellites, and in many ways they look just like our commercial customers do too. There is also, as you touch on, a variety of mission sets for the U.S. government that are not ones that folks are as interested in commercially, although sometimes they are interested in them commercially. They range from protecting satellites on orbit from really usually Russian or Chinese satellites that are nearby. They range from potentially interfering with an enemy asset that is doing services for bad things. They can range to a little bit more complex servicing missions on orbit. So the U.S. government, sometimes a little at the forefront of refueling, is sometimes a little at the forefront of on-orbit repairs or assembly or upgrades in a way that commercial companies don't necessarily have the risk appetite to go bite off at a first pass. All of those are areas that the U.S. government expresses interest to us as we develop rendezvous proximity operations and docking technologies, as we can operate satellites close up to and touch other satellites. I think there's two challenges for us as a business as we grow into those opportunities. And one of those is to figure out what is going to be fundamentally useful over the long term. Because we're not building a business to go try to grab whatever the shiny contract of the moment is. We're trying to build a business that fundamentally provides real value to our customers. And that's true for the government on the same way it is for the commercial side. And then the other factor that we have to decide as we bite off new opportunities is we have an efficient team and we need to focus on the things that are going to give us the most bang for our buck right now. And so that means that the otter is always our core focus at the moment as we build otters, as we fly otters, as we grow that line of business. And the next wave of opportunities to take advantage of our technology, we have to tackle bit by bit as they come, as the right ones come for Starfish, and as we can jump and provide a lot of value to our customers for relatively little effort on our side.
Yes, you mentioned some of our adversaries' kind of actions in space right now, China, Russia. So I wanted to ask, what is the current state of our adversaries' capabilities as it relates to RPO, orbital warfare? I know there was just an announcement late last year about China demonstrating an on-orbit refueling mission. So how are you seeing our adversaries' capabilities, and what role does Starfish and other startups play in maintaining U.S. dominance in the space domain?
Yeah, so I think there's not a lot of broad awareness about what goes on with rendezvous, proximity operations, and docking in space, and what can make space a contested domain. And I understand why there's not always that awareness, because on the other hand, there's a lot of incredible things that happen in space, and not to say that some of what's going on isn't incredible, but there's a lot of excitement, and there's a unique kind of positivity and optimism that often comes with space missions. And sometimes you don't want to think about, oh, this could be a contested domain of warfare also. But we go talk with government customers and actually commercial customers also. And they'll talk about, yeah, there is 10 to 20 kilometers away from us some Russian satellite or some Chinese satellite, and it has no reason to be there except to be poking around at us and trying to figure out and trying to potentially interfere with what we're doing. And these satellites from both commercial and government folks are providing valuable services, and if they went out at the wrong time, that would be a really critical challenge for humans here on Earth. And so they ask us things like, hey, could you guys use your proximity operations to help protect our satellite on orbit? And that's something that our technology can lead to, and it's a real thing that you have to think about, because Russia and China both have proximity operations capabilities, and they have both demonstrated them on orbit. There's multiple Chinese satellites that have docked in geostationary orbit, and there's some speculation that there is refueling being done as part of it. There are Russian assets that have docked and have gotten close to U.S. assets, and I believe even fired little projectiles at U.S. assets. And those capabilities mean that if you have a U.S. satellite that is relaying communications back and forth to Taiwan at a critical moment, and somebody's threatening to disable that, that has a huge impact on the safety and well-being of people here on Earth. And that's something that our technology can help and support. And it's not that we are the only ones who are capable of doing proximity operations and docking for the U.S. The U.S. has those capabilities too. But the U.S. has them in a way that's really expensive. And if I think we see this in a variety of frontiers of conflict right now, if the U.S. is bringing really expensive capabilities to the theater and adversaries are bringing really affordable capabilities, then over time the U.S. is losing the economic battle that comes with conflict. And so I think that is where Starfish Space can make a positive impact, the same way that we can make a positive impact on our purely commercial missions by providing more value from the services that we provide than what it takes for us to provide those services.
Well, I gotta say, this whole conversation is making me exceptionally nervous because it wasn't that long ago that what we're talking about is just totally not taboo, Maggie, like verboten, go to jail, like talking about these elements of orbital warfare, stretching out some of the highest clearances I ever enjoyed in the department. But it's good. I mean, we're seeing this push for these exquisite missions that don't need to also cost an arm and a leg, right? And I think taking a fresh approach, maybe some might say a first principles approach to doing these various missions is like right in the wheelhouse. So, I mean, Austin, maybe just talk a little bit to us about the construct of Starfish, right? How your RPO technology serves a lot of different mission applications. And then more so, how do you articulate that to the variety of stakeholders? Because it's different organizations in the military and the intelligence community who would be interested in life extension versus those that are in orbital debris. But for you as a company building Otter, it's like, it's just Otter. Like, like you don't need a special widget, just use it for different purposes.
Yeah, I mean it's funny, that's always a tricky challenge, especially for technical founders, but I think for everybody in pitching everything that they work on. You get so involved in the details that you need to do to make it work that's what you end up talking about. And in reality, when we're out there and we're selling to customers, and for people's references, we have Otters that we've announced that we've sold their services to the U.S. Space Force, to NASA, to SES's commercial company. We're building all of those now. They're all getting set to launch over the next year here. And when you go out to sell the services of an Otter, a lot of times the people that you're selling to are a bunch of aerospace engineering nerds like yourself. So they're excited to go and talk about proximity operations because they think it's fun. But they're also good at their jobs. And so they're ultimately going to make the decision based off of, do they get value out of signing a contract for our services? And on the commercial side, that actually often turns out to be a really straightforward thing to go and talk to people about, especially if they're a public company. Then the knowledge is kind of out there, and you can go and say, hey, you've got this satellite or this constellation. You make X amount of money per month on that satellite. We can add 5 years to that satellite. We'll charge you Y amount of money per month. X is bigger than Y, and so it is valuable for you to use our services. And on a commercial side, that's a pretty straightforward thing when you're talking to a commercial company. And then you go and talk to the U.S. Space Force, and we can say, hey, you can extend the life of this satellite. We'll charge you Y money. We're curious, how much money is it worth to you a month to have this satellite? And people will look at you like, what the heck are you talking about? Why do you talk about this in terms of dollars? And so it can be a little bit of a trickier proposition to understand the language of the U.S. Space Force there and what is the value that they see from life extension. But we try to talk about it in the same way. We try to talk about, the satellite is gathering critical data. The satellite is a key piece of resolving emergencies. And sometimes you can talk about dollars where you can say, hey, if you were to procure a new satellite for these services, it's going to be like a $2 billion satellite. So you might as well get 5 more years for a whole lot less money than that. NASA may be the trickiest of the entities that we've needed to talk to, because the ultimate value that the U.S. Space Force wants to provide is pretty clear, even if it isn't dollars. Ultimately, they want to protect the U.S. as a nation and our allies and our interests. With NASA, there's some folks there that are going, we want to explore the edges of outer space. There's some folks that are saying, we want to do as much science as possible. There are some folks that are saying, we want to build a technical base. There are some folks that are saying, we just want to create American jobs. All of those are good and valid end goals, but to navigate your way through NASA, you kind of have to understand each group and what their particular interests are going to be. That's an experience that you can navigate and you can learn, but you also have to be repeating it throughout, like, hey, this is what we all agreed that our goals were going to be at the beginning, and those are the goals that we're going to pursue.
So Austin, it sounds like you guys are working with a swath of customers across, military agencies, civilian agencies, as well as completely commercial, non-government agencies. And I know a lot of the terrestrial tech companies we talk with discuss, some of the specific standards and compliance certifications that they need to get through to work with U.S. government customers, to work on classified mission sets. So I wanted to see if you could talk through, what were maybe some of the bigger surprises or challenges or differences that you've had to work through in order to work with some of these government customers on classified mission sets?
Yeah, there are both for classified reasons and unclassified reasons a variety of licenses or approvals or certificates that you need to get to work with the U.S. government in different stages. Starfish Space does have a facility clearance that we got recently, and it does allow us to work on classified missions or work with classified data. That does unlock a variety of additional mission sets and a variety of additional customer organizations for us. It's kind of funny to all go through as an organization and have to figure out how to get that on the back end. I've had clearances in previous lives, both at Blue Origin and at Lockheed Martin. It both places, I kind of had no idea how it came together that the company could work with me to get those. You're just sitting there, and then somebody said, "Hey, you should get a clearance." You go, "Okay, sounds good. I'll fill out the paperwork." It is tricky to get a facilities clearance, and you have to work with folks. I think that the U.S. government is putting a lot of effort into figuring out how to work with companies like ours. I think they see the value that companies like Starfish Space or Impulse Space or Varda or K2 Space or a lot of other great space startups that are out there can provide. I think the trick is actually not just getting the FCL, not just getting the clearances for the individuals, but also being careful about how and when you take on classified work, that there is a lot of overhead to doing work in a classified manner. And there will be a lot of folks that are tempted to just say, "Hey, everything's classified. Let's just be careful and safe here and make sure that everything's classified." And you want to be careful, and you really want to protect the sensitive information that allows our nation to defend itself. But you also have to be careful about how much work you're trying to do in a classified lab, because if you develop some awesome piece of your GNC algorithms that's really going to make your satellite do proximity operations a lot better, and you develop it in a classified lab, to get all of the code and the simulation results and everything back into the unclassified world and apply it to other missions, it's a whole lot more complicated than it otherwise would be if you'd started off in the unclassified world. And so there's both you have to get the paperwork and the approvals, and there's also you have to figure out how to operate with it in a way that is efficient for your business and allows your business to continue to do the things that you want to do. Because at the end of the day, I don't think the classified world, or I don't think working with the government world is really that fundamentally different from any sort of business. You're out there to try to provide value to your customers. You have to build a product that you can actually build, and then it has to deliver that product or the services of the product to your customers in a way that is worthwhile for them. And as painful as it can sometimes be to work with the government, oftentimes when we're talking about, at least for us, the kind of sizes of the contracts that we're working on, the pain of working with the government is a relatively small pain in comparison to the total effort that it takes us to fulfill the mission otherwise. Probably the biggest challenge is not figuring out how to do it or not doing the paperwork. I think the biggest challenge is that it's just going to take a really long time because the government isn't used to operating at the speed of startups. They're trying, man. They're working harder. They're getting better at it, but there's still sometimes where you're like, really? That took us 6 months to pull that off? There's a whole lot that can happen in 6 months at a startup.
Yeah. So, I mean, from a timing and startups and trying to keep the pace of change, ultimately you need to generate revenue. And it seems like a lot of the revenue programs for the military, at least for an early stage startup, is around some of these non-dilutive R&D type opportunities. So talking about Cyber and StratFi. Can you maybe just like walk us through a little bit, like that approach that you took? How did you find the right stakeholders? And how did you turn that SBIR into a StratFi?
Yeah, SBIRs, small business innovative research contracts, are, I think, a really neat thing that the U.S. government does. And a variety of agencies do this. The Department of War, NASA, the Department of Energy, the National Science Foundation, they all give out small business innovative research contracts, although all in a little bit different ways. And these contracts are often broken up into a phase one and a phase two. And a phase one is on the order of about $100,000, and a phase two is on the order of about $1 million. And when you are two people working from a public library, the idea of getting $100,000 to work on your ideas is like an incredible and overwhelming amount of money. And so that was from the very earliest stages for Trevor and I. One of the early things we looked at was small business innovative research contracts. And as we were looking into it, we learned there's kind of a couple of philosophies on how you can use these contracts. You can use these contracts to try to make money and sustain your business. And you can build a company where you're winning several SBIRs a year, and you have a dozen folks working on these SBIRs, and you can operate for several years like that. Or you can really try to use SBIRs as a springboard. And you can try to use these as a way to become the business that ultimately you're trying to achieve. And that is actually what the US government tends to want. That's what the Air Force or the Space Force wants. That's what NASA wants. They want to use these innovative research contracts to develop technology and teams and business relationships that eventually allows these companies to go fulfill needs for the US government and for the commercial world at a large scale. And so we went into these SBIRs going, okay, let's go in a phase one. Let's go turn it into a phase two. And let's ultimately use that as a way to sell our Otter satellites. And that played out almost to a T in multiple avenues for us. So our very first SBIR was a $50,000 contract to study some of our proximity operations. And then we turned that through Space Force Pitch Day into I think it's like a $1.5 million contract. At the time, that was real and substantial money for us. And we turned that eventually into a TACFI, a tactical finance contract, which is a couple $1 million. And through another set of SBIRs, eventually won a StratFi, which in our case is $37.5 million coming from the US government to do an Otter mission at the Space Force. And now we aren't bidding on SBIRs for the Otter or for our key technologies. That's not what our business is about now. But it really was the springboard to the future. And then it turned out people were really excited that we were trying to use SBIRs in that format, that you would go and talk to whoever in the government you thought might buy proximity operations technology, or you might buy Otters. And they would say, this is pretty interesting. I'm not going to go give you a $40 million contract off the bat here, but I'd like to work with you a little bit and see what you're capable of. And you go, okay, well, that's awesome. We actually know about this SBIR framework where we could go do a phase one, or we could go do a phase two if you just write us, a letter of support, and we'll go through the proposal application process. And it doesn't always work. These are competitive proposals, but we kind of lead by talking to the customers, and you take it back, and the SBIR process is just a vehicle that allows you to start working with them more closely.
That's great. And I think, yes, you are using the SBIR program the best way possible. And I wish other companies took that approach and lead. But we don't need to get into that topic here. But maybe we can just drill in a little bit more. Did you feel like you were educating the customer about what you could do with the Otter and starting to unlock RPO? Or did they already have some sort of a knowledge base around it and they were like, oh my God, thank you. I found you. Like, let's go. Like, which way was it? Was it a push or a pull?
I actually think it was a little bit more us educating. And definitely not us educating the Space Force on what they would get value from. They're the ones that can say, oh, yeah, life extension would be valuable, or oh, yeah, proximity operations to do this mission would be valuable for us. Um, but what we could educate on was what was possible and what was possible in different ways. Um, we're not the first ones to go to the U.S. Space Force and say, hey, how about we do a little bit of life extension? Many folks have gone and done that before us. Uh, but we were the first ones to show up and say, we could do life extension for this price point. And the first time we said that to a general, we got some funny looks like, what are you talking about? That's totally out of family with all the price points I've been told in the past. And so it
Did they
took
call
some.
you a heretic at all? Did they say
I don't.
it's
I
voodoo
don't remember being
magic?
called a heretic, fortunately. But I think that people probably appropriately look at ambitious technology startups and go, "You guys are crazy. Like you're just out here saying stuff. You're not going to be able to pull that off." And so you have to fight your way through what is, I think, an appropriate level of skepticism. And to some degree, you can go do that and present to them like, no, here's the breakdown. Here's why we as a business would actually like make money by providing the services to you at the price point we talked about.
Last question on like sort of this general topic. I mean, I'd love to hear like how many conversations did it require from you and your team, and probably a very small team in those early days, to get that phase one into a phase two, that phase two or series of phase twos into a TAC-FI, and then eventually a strat-FI. And then did you arm yourself with like other third party consultants, whether they be supporting you through proposal development or lobbying even?
The one that is maybe the easiest to track is going from the phase one to the phase two. In early stages, we had very clear and dedicated pipelines because that was before we really knew many folks in the U.S. government. Sometimes now we can short circuit the process a little bit for something like that. We can go, all right, here's the three folks that we know that are most likely to support it. Let's just go and talk right to them. But when we're trying to take our first phase one to a phase two, I think we had 30 to 40 dedicated conversations with different folks that we thought might potentially be able to support the phase two in the US government. And we had those conversations through all sorts of forums. It would be in person in conferences. It would be through warm connections over Zoom calls. It would be through accelerator or startup mixers. It would be sometimes people that just randomly showed up to one of our SBIR deliverables that we were putting together because they'd heard about us. But I think it was ultimately like 30 to 40 conversations. And then if you take a look at like, well, hey, what does it take to get from the very earliest stages to a strat-FI? It's hundreds and hundreds of conversations between Starfish Space and folks in the US Space Force. You want to be careful. You want to be efficient with those conversations. You're not just talking with the same person over and over 100 times. Like they have things to do too. But you want to cast a wide net and allows you to eventually find like, here's the people that are going to that are most interested and can most benefit from what we're building. We did and have and continue to in various ways work with some third-party organizations along the way. In the very earliest stages, we had no idea how SBIRs worked. I think we lost our first 11 SBIR proposals. And so we started working with some consultants who were really knowledgeable about the SBIR process. And they show up and there's some things that they tell you from day one that are like, oh, you're not actually trying to put the most advanced technology descriptions in there because it's not scientists that are reviewing the SBIRs. You need to talk about how your business is viable and how what you're doing would be useful. And that's what the Air Force likes to go and evaluate SBIRs on. And so we got some of the tips. We figured it out. We started learning how to win the SBIRs. And eventually you get to a point as a business where you go, great, we figured it out. And we don't even need SBIRs as much anymore. And so these folks that did a great job for us at a certain stage, that particular skill set isn't as useful for the next stage. So we go, thanks for all your help. We're going to refer other companies to you. And, we're going to move on to the next stage of our development as a company. And so that's all sort of what drives us to go, hey, we don't hire and bring some SBIR expert in-house. We hire and bring in really, really capable people who are great problem solvers generally in-house. And we'll bring in a little bit of third-party support along the way. And we did that in the SBIR stage, and we did that in the StratFi stage. And we do that now with some of the government affairs or some of the policy work that we're doing. All of those are supplemental. At the end of the day, only you and your team can tell the story the way that you and your team can. So you still have to get in there and get your hands dirty. You don't just hand it off. But as advisors, the third parties, I think, can be useful services at times. David, Maggie, what do you guys see other companies do? What do you recommend when you're talking to some super early founder that is just getting going and saying, I think I might want some of these?
I mean, I think what we've seen be successful is the founders, especially in those early days, need to be at the vanguard of those conversations and finding their champion. And what I see from the military folks is they really do like talking to founders, right? The people that are going to like build the thing. That's actually kind of novel to them. But as far as, you talked about, I didn't understand all the elements of an SBIR. To me, I would advise the startup founder not to go figure it out for themselves. Like that is a lot of effort and likely wasted effort, and you can pay for those types of services. The key is, can you find a good trusted source to help you? And that's where leaning on your investors who are deeply experienced in this domain becomes quite clear, and why, as a startup wanting to engage in the defense ecosystem, you should, pick your investors and your advisors wisely. So, I mean, the way you guys went about it, I think was absolutely perfect. And I think the rewards speak for themselves.
I mean, Austin, another question I had, unlike a lot of the companies that raise venture money where they're able to build an MVP in a month or, maybe even a hackathon over a weekend, you guys are building a really complex piece of technology that has taken years to build and prototype and launch and test. So I'm curious, how do you build a go-to-market sales engine while you are still proving out a piece of technology?
I think probably fundamentally the biggest challenge for our business is that we have ambitious goals, and it's really challenging to build a bunch of satellites that extend and protect and upgrade and improve infrastructure in space. We can't just go out and be like, look at our revenue, it's going up 30% month over month, and we sell, $10 at a time subscriptions, and it's a nice hockey stick graph. You have to get folks of all sorts to buy in on the risk along the way. And that's customers need to buy in and take some of the risk with you. It's investors need to buy in and take some of that risk. It's employees. It's suppliers. Everybody that you work with is betting on you a little bit in one way or another. And one of the things that you have to do is construct your development plan as a business in a way that allows people to see the risk reducing, allows people to see progress all along the way. And that allows everybody else to buy in a little bit more. And so you might sit there at the beginning and say, okay, this is going to cost us $100 million to design and get to flying the first satellite. But you can't go out and just get $100 million from your customers, from your investors, when you're two guys that are sitting in a library. And even if you did, you're not going to know what are the right things for you to do. You can't just be like, well, let me get $100 million and turn it into a satellite. You always have to have the steps and the milestones along the way. And some of that is your key technology development. And some of that is pieces of your system architecture. And some of that is demonstration missions. And those are all on the technology side. And some of those are early contracts and conversations with customers. Phase one SBIRs can fit the bill there. Letters of interest, or we did something that we call development partnerships with commercial customers. Those can really fit the bill. Uh, Early rounds of investment, pre-seed rounds, seed rounds, Series A rounds, those all help do the risk reduction. Hiring great early employees. Sometimes in the proposal process, you go like, okay, well, we just have to make these, we have to send these couple of people's resumes in because that's going to be a key part of why people want to work with us is they go, oh, look at this awesome team that you're building. You have to have the little milestones and you have to get people to buy in on the little bit of risk. And that's true in basically everything that we do. And so go to market is a part of that, that the customers that we work with today are generally customers that we've been on the journey with for years at this point. And they were the first ones on the commercial side to sign LOIs for us. They were first ones to just pick up the phone when we said, hey, we're a couple of crazy folks in the library and we just want to pick your brain and see if this would be valuable at all. And then they were the first ones to dive in on the development partnerships and the first ones to sign up on contracts. And the same way on the government side, you start off with like who's willing to talk with you when you're going through the hyperspace challenge accelerator, and then who's maybe willing to sign a CRADA, and who do you talk with on your very first phase one SBIRs. And there's a lot of people that start working with you there, and if you buy the risk off along the way, they're the ones that eventually maybe they aren't signing the big contract or the big contracts, but they're in the meeting in the hallways with those people saying, you should really take a look at this company. They've been doing impressive work.
Yeah, Austin, since you guys started the company in 2019, you now have launched, 2 satellites. You just completed this Remora mission successfully. Can you tell us about some of the lessons learned from each of those experiments testing your technology actually in space?
It's funny, you set out to test the key pieces of your technology, and you do learn things about the key pieces of your technology. You go do you go fly some missions. You're like, you know what? We actually have some Star Tracker outages every once in a while, and so we have to update our filters so they're not expecting measurements on a regular basis. And this is what our GPS error profile actually looks like, and this is the number of dead pixels we're seeing, or the spurious bright flashes that we see in the background that we need to filter out in our images. And so there's some technical things that you really learn about your key technology. But there are a lot of other things that you learn about along the way too. You learn about how to operate a satellite, how to get the data down in ways that people can look at it, how to send your commands up in ways that are efficient and you can move through your testing operations quickly. You learn how to manage a satellite program, even when you're working with vendors, and we work heavily with vendors to build the components. Just getting the vendors to deliver on time and to talk to each other in a way that everything interfaces correctly turns out to be a huge amount of effort and something that we have to pay a ton of attention to as we build the otters. You learn a little bit about your team and what it takes to be ready for the moments of stress and challenge that you have to resolve, and what it takes to be ready to do that.
Awesome. Well, Austin, you've been, I don't know, super generous with your time. And I know you'd probably be rather in the lab building or closing customers. But before we let you go, I think we just kind of love to hear a little bit of you and how you think about the future of space in the next, I don't know, 5 to 10 years. Maybe 10 years is too far along if we really think about what's happened in the preceding 10 years. But over the next 5 years, and I know you're a visionary, you wouldn't have come up with the name, Starfish in the first place and all of the fun names that you have for all of the componentry. But maybe one area that I would be really curious on your take within this 5-year journey is how the various orbits play into each other.
It's easy in the space industry to dream really big and then to not fulfill and follow through on it. And more often than not, when you ask what does the space industry look like in 5 years, it kind of looks a lot like today. And so I think the areas where it's changing are the ones that are most interesting to call out. And areas where it's changing is not necessarily announcements of, oh man, we're going to land humans on the moon. in 4 years. We announced the same thing, 6 years ago, and didn't really make that much progress along. And I don't think we're going to have a bunch of people wandering around on the moon in 4 years. But the areas where you can already start to see the change, the increasingly rapid launch and the landing of rockets. And obviously SpaceX is absolutely at the forefront there. But Blue Origin also recently landed a rocket that took things to orbit. And Stoke Space is working hard on it, and Rocket Lab is working hard on it, and Starship with SpaceX is working on it, and you can already see that progress happening. I think that as more folks enter the launch market, that's just better and better for people that want to send things into space and get value out of it. You saw a trend for a long time of satellites getting smaller. And now you see a trend of satellites getting bigger again because people go, oh, crap, I want to get a bunch of capability into this satellite. I want to have all the data throughput. I want to have the exquisite camera capabilities or compute capabilities. And all your satellites went down to 3U CubeSats, and now they're all going back to 1,000-kilogram satellites and perhaps even bigger. Some folks are really on the leading edge of that, taking advantage of it. I think K2 Space is an awesome example, and you can see other folks like us. Astronos is a great company that are going, hey, it's not just a world of cube satellites in really low Earth orbit. There's a lot of opportunities in geostationary orbit in particular. And so maybe to touch on your particular question, David, I feel like there are 4 real orbits that people talk about, at least from a commercial perspective, as potentially having value. There's low Earth orbit. There is MEO, mid-Earth orbit. There is geostationary Earth orbit. And then there's cislunar orbit, which is around the moon, basically. And in low Earth orbit, I mean, the biggest thing that's going on in the space industry right now is Starlink and internet service providers from low Earth orbit satellite constellations. And Starlink is absolutely very much at the forefront, and what they're doing is really incredible. And then you see folks like OneWeb and Amazon Kuiper that are following along that. There is just tremendous and huge growth going on in LEO, and that's going to accelerate. In mid-Earth orbit, the biggest thing going on there is the GPS constellation, and GPS is really critical for what people do in a variety of different ways. From a commercial side, being in mid-Earth orbit, frankly, comes with a lot of radiation challenges that sometimes force you into traditional production lines in the aerospace industry that are long and expensive and very difficult to work with. And so I don't know that MEO is going to be a very popular place for folks doing new things. Maybe there'll be some use cases, but boy, the radiation of Van Allen belts can kind of make it difficult. Then you have geostationary orbit. And as you're building big, exquisite assets that cost millions or billions of dollars, sometimes putting them in a place where they're over the same spot on Earth and you can trust for them to be there the entire time turns out to be really valuable. And that was really valuable 50, 60 years ago when people first started launching geosatellites. And I think it's still going to continue to be really valuable going forward. And so there's a lot of folks that are looking at geostationary orbit with a lot of interest, and it's a key part of what I think we're building our business around. And then there's cislunar orbit, and people like to talk about cislunar orbit, but I don't think we're going to see a lot of exciting activity in cislunar orbit over the next 5 years. I really hope that we do someday because, oh my gosh, how cool to see people on the moon or operating around the moon. I think that beyond Earth's realm of orbit, let's send things to Mars, let's send things to Venus, let's send things to the moons of Saturn and Jupiter. That's so cool. And that's ultimately some of the absolute most interesting things going on in the space industry. Maybe unfortunately, if you're trying to build a business around it, you have to take it with a little dose of realism over the 5-year time horizon too. And you got to say, all right, well, we're not building our business to focus on servicing cislunar satellites right now. Let's see some satellites there first.
Great. Well, Austin, thank you so much for taking the time and for coming on the Mission Matters podcast. We're super excited to be investors in your business and excited to see where you all take it from here.
Hey, thank you guys always for having me. Always good to chat with you. And I'm sure I'll see you somewhere soon.
Have a good one.
Sounds good. Thanks, Austin.
Hey, everyone. Thanks for listening to the Mission Matters podcast from Shield Capital. Tune in again next month for another conversation with founders building for a mission that matters. And if you yourself are looking to build in the national security space, please reach out to us.